Here we go. Advent of Code 2018, Day 9. Marble Mania. You talk to the elves while you wait for your navigation system to initialize. To pass the time, they introduce you to their favorite marble game. Is that just a link to Wikipedia Marbles? Toy? Yeah. The elves play this game by taking turns arranging marbles in a circle according to very particular rules. The marbles are numbered starting with 0 and increasing by 1 until every marble has a number. First marble numbered 0 is placed in the circle. At this point, while it contains only a single marble, it's still a circle. Okay. The marble is both clockwise from itself and counterclockwise from itself. The marble is designated the current marble. This is getting very complicated, isn't it? Then each elf takes a turn placing the lowest numbered remaining marble into the circle between the marbles that are 1 and 2 marbles clockwise of the current marble. When the circle is large enough, this means that there is one marble between the marble that was just placed and the current marble. I'm sure I'll understand this in a minute. The marble that was just placed then becomes the current marble. However, if the marble that is about to be placed has a number which is a multiple of 23, something entirely different happens. First, the current player keeps the marble they would have placed, adding it to their score. In addition, the 7 marbles counterclockwise from the current marble is removed from the circle and also added to the current player's score. The marble located immediately clockwise of the marble that was removed becomes the new current marble. This is insane. All right, this is like Josephus, but not Josephus, right? For example, suppose there are 9 players. After the marble with value 0 is placed in the middle, each player, shown in square brackets, takes a turn. The result of each of those turns would produce circles of marbles like this, where clockwise is the right. The resulting current marble is in parentheses. All right, so this is the game starting position. Player 1 says there are 9 players. So we can see 1 through 9, 1 through 9, 1 through 7. Okay. So the first marble gets placed 1. I thought it was 2 to the right, but it just loops around, right? So 1, 2, and it just gets placed 2 to the right. Between the marbles that are 1 and 2 marbles clockwise. Okay. So if this is the current marble, we put the next marble 4. The next marble is 5. It gets put between the 2 and the 1 marbles. Okay. Why does it matter how many players there are? Because the marbles just go in the same spot. I guess, the number of players determines the scoring, right? Who gets what score? I got it. So let's go to the 23rd marble here. Yeah, 21, 22, and then 23 doesn't get placed. Oh, they'll probably describe it here. Goal is to be the player with the highest score after the last marble is used up. Assuming the example above ends at marble number 25, the winning score is 23 plus 9 equals 32 because player 5 kept marble 23 and removed marble 9. What was the rule for removing? 7 marbles counterclockwise. This is crazy. Okay. Well, I mean, we can just implement this just using a vec deck, right? And then rotating what needs to happen. The 7 is going to be interesting. Counterclockwise. And then we're going to take out 23, or we didn't put 23, and then we take out the 9. 1, 2, 3, 4, 5, 6, 7. And then the 19 becomes current because the marble located immediately clockwise and the marble that was removed becomes the new current marble. Okay. All right. We can do this. Let's add this. Create the module. 19, oops, 09, it should be 1809. Oh, I can't do it that way, huh? Now it's broken. Okay. I did an R instead of an insert. That's bad. So it broke all these guys. All right. Associated function is never used. Let's use it. Okay, and we get, if we run, unsolved, unsolved. Perfect. All right, so I think the right approach, and we're going to just do it using this test data here. We have 25 marbles and 9 players. Oh, wait, what's the input? To begin with, get your puzzle input. Oh, I wasn't supposed to click it. I was supposed to do get input over here. And it's just this one line. 411 players, and the last marble is worth 71 plus 1,000 points. Okay. Okay, so this is how many rounds we're going to be doing. 71,000 rounds. That's not too bad. We can do 71,000 rounds. And the players just determine who gets what score. I wonder if it's like directly calculatable. Like if you have 10 players and 16, 18 points, you can just directly calculate and get 8317. All we need here is the number of marbles. And let's make them I64s so that we don't have to worry about. So player count. Again, I'm using I64s only because I don't want to have to complain about negatives. Player count and marble count. And what we'll do in parse here is we'll just generate that self player count equals 9, self marble count equals 25. And we'll see if we can come up with this output. Right, so all we're going to do here for each player, let mut score equals vec bang 0 I64 semicolon self player count. All right, so this is just an array of zeros, and we'll add to it every time we hit a marble that is a multiple of 23. Like it says right there. So for m in 0 dot dot self marble count, we do need to set up a playground, a playing circle. So we can create that here. Let mut circle, and I'm just going to say vec dec new here, and then we'll have to import that because it's not imported by default. So we're going to start off the circle with a 0 in it. The circle push back 0. Let's make them I64s just to keep everything consistent. All right. So what we're going to do is each time we have a marble that's not a mod 23, right? We can say if m mod 23 equals 0, handle the scoring situation. Else, that didn't format. How come that didn't format? Else, handle the placement situation. Right? There we go. That formatted. All right, so the placement is we go 2 marbles counterclockwise. Oh, 2 marbles clockwise. Sorry. That are 1 and 2 marbles clockwise of the current marble. So what I'm going to say is that our current marble, quote unquote, current marble, is the one that's at the front of the queue. So in order to go between 1 and 2, so our current marble is 4. So the queue is going to start 4, 2, 1, 3, and then have 0 at the end. So in order to get the next marble being the current marble, what we'll do is we'll take 4 and put it at the end. We'll take 2 and put it at the end. And then we'll insert 5 at the beginning. Right? Or we could insert 5 at the end at that point. Either one works. Because it's just, no, but we want it to be the current marble. So we'll put it at the beginning. Okay, so all we have to do is say twice let, and I don't think we care about the we do care about the marble count because it's the value that we care about. So let head equals circle pop front, and then we'll just say push back. Head. Okay, and we do that twice. And then we'll say push circle push front M. Right? We should be able to do that at least. And I don't know if I want to print out, let's hit run here. Yeah, it runs. And we can look at the queue every time we get it, right? So we can just say println circle. And we can see what it looks like. And that blew up. Nope. Oh, that was interesting. It built, but until I had to do it, it didn't build. What's wrong with this? Oh, this is an option. Okay, so unwrap. There we go. All right. So is this close? Oh, yeah, we're not using a score yet. Is this close to this? And the only difference is, and I wonder if I should just do this, is that we have zeros. The zeros are here instead. But as long as the order is correct. So 210 is right. 3012, that's correct. Let's look at 22 because that's the one before. So it's 22, 11, 1, 12, and so on. And then it goes 0, 16, 8, 17, 4, 18, 9. Okay, so this part's working. And the current marble is always the one at the beginning. And you notice it skipped 23 because that has to handle the scoring position. Okay, so then 23 becomes the scoring position. So we can say whoever the current player is, which we don't have that information, unfortunately. Let's add that. And then after here, what we can do is we can just say current player plus equals current player plus 1 mod self player count as you size. Who did that? Somebody with a name I can't pronounce. AFCZD Squigs. Squigs. Can I call you Squigs? Thank you for the follow. Welcome to the channel. Glad to have you here. So then what we can do here is score of current player plus equals the current marble value plus the one that's 7 to the left. Seven to the left. So that would mean doing the opposite of this thing here, right? We can do in 0.7. We're going to do this back the other way around. So our current marble is 23, and we want to do 7 to the left, which is going to be 1, 2, 3, 4, 5, 6, 7. Yeah, that's the 9. So we're going to pop back and push front 6 times. And then the last one will pop back and then add that to our score. And then 19 will be at the front, I believe. Let's find out. So we want to do this 6 times. Let tail equals circle, pop back, unwrap, circle, push front, tail, and then we're going to say score of current player plus equals circle, pop back, unwrap. Okay, so let's see if this works. Let's run this. And it blowed up. It done blowed up. We unwrapped a none. At line 43. That means the circle became empty somehow, and that shouldn't have ever happened. So it's got to be something in here where I'm breaking. That doesn't make sense, though. Well, let's find out. Let's print out what the circle looks like. After scoring current player, circle is circle. And I don't have any output at all. Oh, because I'm starting at 0, because I'm a dum-dum. Right? We already had 0 here, so we got to start at 1. All right. So let's see, does that work? The current marble becomes 19, and then it's 2, 20, 10, 1, and so on. Perfect. And then the current marble, oh no, it's 24 is right. Oh, I just never did the 25. Okay, I actually have to put the 25 in there, so this has to be equals. Right. And what we can also do is add, just to be on the safe side, add current player to the list of things here. Current player. Right. And we can see that it ends on 7, just like this does. Wunderbar. So that means we actually have, and what are we looking for? Player with the highest. What is the winning elf's score? Excuse me, I just need to take a quick drink. What is the winning elf's score? All right, so, and that's just getting the max of the scores. Score max. All right. Iter max. Unwrap. Flip over here. We get 32. That sounds right because that's a test input. 32. Perfect. Okay, so now let's do it with the real input. Oh, which we never actually did, right? We have this data. I hit Control-Z in the wrong window. I don't know what. Yeah, okay, so that's still working. We just have this thing here, so we just need to pull out 0, 1, 2, 3, 4, 5, and 6. 0 and 6 for the players and the points. So that's easy enough. So this is our test data. Let's do let lines is equal to AOC lib read lines input 2018 what day are we on? I've forgotten. 09 dot text. First, unwrap. That gets us a string. And then we can say let words equals lines dot split white space dot collect vec. Right? That's a vec of strings. And now we can say let player count, self player count equals words. Oh no, this first one's the marbles. No, it's players. Okay. Words of 0 dot parse dot unwrap. and self.marble count is equal to, oh, I don't want to print this out then. Because that'll be a lot of output for 71,000 marbles. Words of, was it 6? Parse, unwrap? That's all we need to do. Temporary value, yeah. Clone. All right, let's run it. See what happens. Oh, it came up with an answer in a relatively short amount of time, 3 milliseconds. I was expecting it to take a little longer, maybe a second or so, but that's good. I guess Rust is pretty efficient, and this is debug mode, so. Hey, good, that's the right answer. I am happy. Let's get rid of this println. And then Clippy was already okay with it, so I think that's all. I'll leave these lines in here for the test data. Yeah, I think we're good. It's pretty basic stuff. Okay, git commit -am 2018 day 9 part 1. Let's see what day 9 part 2 has. Amused by the speed of your answer, the elves are curious. What would the new winning elf's score be if the number of the last marble were 100 times larger? This smells like a... Every so often, Advent of Code will have, and it happens a few times per event, that part 2 will be, okay, here's part 1, but times 1 billion. So if you made an inefficient or non-optimal solution for part 1, part 2 will take more than the lifetime of the universe to solve. But 100 times larger doesn't seem like that. So I'm going to just give it a shot. And we're going to have to do some refactoring, obviously, right? Because this is no longer just part 1. We're going to actually rip this all out. Like that, and stick it in a function where we tell it how many marbles to do. Solve for marbles I64, and it returns an I64. We need an open brace, and we also need a close brace. And now we have a solve for that returns the max score, max, iter max, unwrap. Right, and now here, instead of self marble count, we're going to just say marbles. This is going to take a self. And I think that's all we need. Right? And then this becomes, part 1 becomes, instead of output score, blah, 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 we say self solve for self marble count. Right? And then that should give us the same number. Let's find out. 425688. Oh, I got to deref it. 425688. And now part 2, let's find out. Because if this takes 100 times longer, right, that'll still be less than a half a second. If it's linear like that. Let's find out if it's linear. Self solve. It should be linear. Self marble count times 100. Right? Should be linear. Yeah, it pretty much, right? It did come up with a huge number. And it's the right answer. So, okay, that was quick. (2018) day 9 part 2 done. All right, let's push those. And I still have time. I've done two. I'm not going to do a third one because that'll just break my brain. Let's take a look at the advent calendar. The sleigh is almost fully in. I guess I'm expecting it to get colored at some point.